Ice cores and climatographs. Have you ever wondered about ice, especially the ice in glaciers? Yeah, me neither. It may not sound like the most engaging topic. It is just frozen water after all, but ice cores are actually more interesting than you think. Let's start at the basics. What's a proxy record, and why should I care? Well, proxy records are sources of climate information from natural archives such as tree rings, ice cores, and even ocean sediments. To be concise, they just tell us about past climate conditions through evidence found in nature. But wait, why should I care? Well, you should care because proxy records help scientists who look at past weather conditions, also known as climatologists, compare climate then and climate now. This can essentially help us be more environmentally aware and understand how big of a threat climate change really is to us. Either way, let's get on to it. Ice cores are just long cylindrical pieces of ice drilled out of a glacier. The ice at the top is more recent, whereas the ice on the bottom can be up to 800,000 years old. The reason climatologists are so hung over ice cores in the first place is because the ice is able to trap air from different time periods. What this means is that an 800,000-year-old ice core can have 800,000-year-old air trapped inside it. Moreover, the air contains a variety of greenhouse gases, which are carbon dioxide, methane, and nitrous oxide. When we apply this to what we previously learned, we can theoretically see the atmospheric greenhouse gas composition from 800,000 years ago. This is great for climatologists because then they can compare our current greenhouse gas levels to those of the past. A good way to think about it is an ice core as just being a giant library of reference values for greenhouse gas compositions. But wait, there's more! In addition to the greenhouse gases trapped inside the air bubbles, scientists can also determine what the air temperature at the time was. How does one do this, you may ask? Well, as we learned in the chemistry unit, there are different types of atoms, even within a specific element. That rule comes to play here, as there are many different types of oxygen atoms, and the weight of those atoms can help us find out the air temperature. The way it works is that the lighter the oxygen atoms, the colder the air temperature. This means the heavier the oxygen atoms, the warmer the air temperature. Climatologists again use this data as reference, as a cold air temperature means low levels of greenhouse gases in the air, and a warm air temperature means high levels of greenhouse gases in the air. Now that you're familiar with ice cores and what they can do for us, let's talk about the extraction method a bit. Ice cores can be up to 3,000 meters long and take several weeks with specialized equipment just to extract. Once extracted, the ice gets cut up into thin pieces so that the air bubbles can be easily reached to test in a construction line. Now, let's talk about climatographs. Well, what are they? They're specialized graphs that record and measure the precipitation and temperature values of a specific location over a 12-month period. If you pass grade 9 geography, this should ring a couple of bells. Hold on a sec though. Why are climatographs important in the first place? What are they so special for? Well, a climatologist can use a single climatograph to predict future climate and weather in the respective location. For example, a climatologist can use a Brampton climatograph to predict the weather and climate in Brampton. Some sources say that a climatograph's predictions and values are valid up until 30 years until the data would be considered invalid to be used. Nice one, climatographs. If you liked our video, or didn't, be sure to drop some feedback for future videos.